Hey friend, welcome to another episode of Interview Problems. This time we're talking Fibonacci and the Fibonacci series, and we're going to use Python to solve this. Now, the Fibonacci series is very interesting, and it also involves using recursion as part of solving this problem. But let's have a bit of honesty here. Recursion is something I've definitely seen being used at university. I haven't seen it so much in the wild, meaning that a lot of people tend to use for loops or while loops to solve it instead. But for some problems, especially the Fibonacci series or working with lists, for example, it makes a lot of sense to use recursion. A little bit about recursion, if you never heard of it, it is a function that calls itself pretty much. So what do we know about Fibonacci? What do we know about our problem space? Well, for one, we know that with Fibonacci, you have a function here, right? And you see that this function result fn is the result of calling the same function, but this time with one value smaller and this time with another value smaller. So it's about summarizing the two last responses. So we can look at this without looking at the function, we can look at it on pure numbers. So if you see, for example, this is the result of summing up 0 and 1, and this one is the result of summing up this one, this one, and this one. This one is the result of summing up these two, and so on. So it's always the two last responses in the series. So the 5 is the result of 3 and 2, but not the 1. So how do we implement? Well, there are some basic conditions that we need to care about. Those basic conditions are that if I send in a 0 in my function, I get a 0 back. If I send in a 1, I get a 1 back. But for all other numbers where n is larger than 1, this is the equation. Right, so if we start writing our function and take away this condition, because this is everything, we see that we try to implement our basic conditions. What we're saying is if n equals 0, then return a 0, that's this condition. If n equals 1, then return a 1, that's this condition. And now what we have left is how do we implement this one. And this is where it's really great to deal with recursion, functions calling themselves. So let's enable this code and look at it. We see here how we are calling this function exactly like we do here. We call it with our own function, so we call ourselves again, this time with n-1 and this time with n-2, and you see that this operator is here. So one thing that's important as part of this is not only to call these functions with different input values, but also to return the end result. And so what we can do then is to try out and make sure that this list that is known, this is a correct Fibonacci series, checks out. So we can run our Fibonacci function for various scenarios. So n equals 1, we get a 1. What happens if we input a 0? We get a 0, right? If we input 2, then we still get a 1 as end result. If we put in a 4, that means that we should just move along this number axis. So we see that if we input a 4, we are here. If we put in a 5, we get a 5. If we put in a 6, then we should then get an 8, right? Which we do. And just our final test here is input a 7, which is 13. Now, what is the interviewer likely to ask you to do? Well, first of all, you shouldn't give away the entire solution even though you know the entire algorithm. It doesn't take that long to implement it. What you need to do is to talk loud and say, okay, I recognize that there are some basic conditions. I should probably start with these basic conditions. That's a good start. That's what we expect from a developer. You take what's known and then you kind of save the harder part for later. So you do that, you implement those, you run the code, make sure that those check out. Then you start adding your more complicated condition and you talk them through the fact that, hey, I need to add these two together, I need to return this, and so on. So gradually reveal your solution and wait for your interviewer to ask any kind of clarifying questions. So don't rush problems like these. Implement the basic conditions first, then make it more complicated. Your interviewer might also ask you to have a check for this one. I haven't implemented a check, so you are free to implement -1, which probably won't end well. So your interviewer might definitely tell you to do a check for -1. So how would you implement that? Would you crash the program? Would you just return -1, for example? It's a bit up to you. I have left this open-ended on purpose. But hopefully now you understand what is Fibonacci. It's this series, it's these conditions. What should I use to implement it? I should be using recursions. What questions am I likely to get? Well, it kind of depends on your interviewer, but they definitely want you to check for, you know, conditions and make sure that you implement this especially. So you shouldn't be able to, definitely not able to input -1 or minus whatever. Hopefully you felt that this was a good video, so I'd really appreciate any likes, any comments, how I can improve things, and I would super appreciate a subscribe. So I hope I see you in the next video.